19.5 congruent figures. I can apply a sequence of transformations and determine the pre-image and the image are congruent. So just as a reminder, congruent means two figures that can be obtained from the other by rigid motion. Congruent also means that they're going to be equal. Everything about them will be the same. All right, so two figures, one can be obtained by rigid motion to get the other, and it will be exactly the same shape-wise. Okay, so same lengths, same shape, nothing about what it will be changed except where it is possibly. Okay, so first we're going to just work on identifying a sequence that would get the one to the other. So a sequence meaning more than one. We cannot just do one thing to this, but we also don't have to just do a specific, right? Sometimes you might figure out a different sequence than I do, but it could still work. So that's also what's kind of nice about sequences. We can get a couple of things. All right, I can do it one way, you can do it another, we can do the same thing. So we need to identify the sequence. It says A to B, so we're going to move the blue to the green. Based off this, I can kind of tell that there might be a reflection, and it looks like it's a reflection over the y-axis, because if I look, they're opposites of each other. Now I know it's not a perfect mirror, but that's because I know I have to do more than one thing. So let's start with a reflection over the y-axis. So I'm moving A. It's 1 over 1, 1, 2, 3, 4. So 1, 2, 3, 4. 1, 2, 1, 2. 1, 2, 3. And then 1, 2, 3, 4 right up here. All right. So there's 1. I could also say, you know, x, y goes to y-axis, so opposite x's. Okay? Looks like it's going to work if I now just slide it 1 to the left. So I'm going to translate 1 to the left. So I can then say x, y. And since I'm moving to the left, it's going to be x minus 1. And I'm going to leave the y's alone. And if I slide all these over, 1 over, 1 over, 1, 1, 1, all to the left. So it worked. So that's what they mean by a sequence. 2 or more things done. Very specific. That's what they mean by rigid. You have to follow these rules to get to the other. Okay, so B, identify a sequence of transformations that will transform figure B into figure C. So blue to green. This might be a good place to pause. See if you can figure it out. See if you can find a transformation or sequence of transformations that would work. All right. So based off the orientation, I can tell that the shape's turned. Right? It hasn't been reflected. It's not the same thing just over here upside down, and it's not over here flipped like A up above. It's been turned. That shape has been turned. A turn is a rotation. So I'm going to rotate. And if it's in this quadrant, so it's going that way, that's clockwise. And it looks like it's only maybe moving one quadrant, so that'd be a 90. So 90, oh, that's counterclockwise. Sorry, counterclockwise. So I could say x, y, 2. Remember, we flip. Counter makes the y's go to their opposite. That's that rule. So if I check that, I'm going to flip them and change them to their opposites, right? So here we go. That's why I like listing them, but that's okay. 5, 1 is 1, 5. And then 3, 3 would be 3, 3, that's kind of a nice one. 4, 2 is 2, 4. I'm doing this right. And then 5, 4 will be 4, 5. I think I have this one in the wrong place. Let's see. I think it's okay. Oh no, it's a little big. What'd I do? All right, I'm gonna write the points down. See, can't do it visually. Negative 2, 1 will go to negative 1, negative 2. And negative 3, 3 will go to negative 3, negative 3. Negative 4, 2 goes to negative 2, negative 4. Negative 5, 1 goes to negative 1, negative 5. And negative 5, 4 will go to negative 4, negative 5. Maybe I was right, it just looked weird. Negative 1, 2. Negative 3, negative 3. 2, negative 4. Negative 1, 5. And then 5, negative 4, 5. Oh yeah, there we go, much better. Oops. There we go. Sorry, guys. All right, so then obviously, so it's now in the shape's right place, but it needs to be lifted up. So we're going to translate up, how many? 1, 2, and 1 right, because I need to slide it back 1. So we would write it as x, y goes to, right is adding, so plus 1 here, and then y plus 2 here. So if I look, I go 1, 2, 1, good. 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1. So it works. All right, so here's one more. So you need to identify, pause, identify a sequence that might work. And we'll actually, pause, take your time, but then I'm going to go over this in class. So we we'll see all the different versions based off what you guys put in your form, okay? So make sure you put your sequence in your form, either in rules or, so algebraic or verbal. But make sure you do that. I'll make sure there's a question for that, okay? So, find your sequence, see if you can come up with this on your own. All right, so just main thing I want to remember is that sequence more than 1, 2 or more, okay? And these will cause them to be congruent. Everything about them is the same. All right, so here's 3. This is your independent practice. Same thing as the last one. Again, come up with it, see what happens. And then we'll compare them when we get back to class. All right, until next time.